I welcome you all for the session 12 on interference of light. Here we shall discuss about the Lloyd's single mirror. Lloyd's mirror is an optical device for producing interference fringes devised by Dr. H. Lloyd in 1834. It is a single mirror of focal length about a 30 centimeter and breadth about a 5 centimeter, made of either polished metal or highly polished black glass, so that reflection occurs only from the front surface. When light from a slit S is made to fall at a grazing incidence, the light reflected from the mirror appears to come from the virtual image S1. Thus, the direct light from S and the light from the virtual slit S1 superimpose in the region AB on the screen to produce the interference pattern with straight fringes parallel to the slit as shown in the figure. Fringes are formed only on one side of the central fringe, that is not visible, corresponds to point C of equal path difference from the two sources. Central fringe can be made visible by introducing a thin mica sheet of a certain thickness T, so that extra path difference of mu minus 1 into T is introduced in the path of one beam. Okay, here one thing we should note that the central fringe in the case is dark, which according to theoretical consideration must be bright. The reason for central dark fringe is due to a phase change of pi on a reflection from the denser glass plate. Thus, the wave from the two sources have the initial phase difference of pi at the time of emission itself. Due to a reason mentioned in note 2, the condition for constructive interference is to get bright fringes is delta is equal to x into small d divided by capital D, which is equal to 2n plus 1 into lambda by 2, and the condition for destructive interference is delta is equal to xd divided by capital D, which is equal to n lambda. Okay. Thickness of a transparent plate using a biprism. When the light from the source passes through the glass plate, an extra path difference is introduced by glass plate. The distance travelled in the glass plate is equal to small t. The distance travelled in air is equal to AP minus t. If c and v are velocities of light and light in air and glass respectively, then the time taken to travel distance from A to P is equal to AP minus t divided by c plus t by v, which is equal to AP minus t divided by c plus mu t by c, which is equal to AP plus mu minus 1 into t divided by c. Due to the introduction of a glass plate, the ray from A travels a path is equal to AP plus mu minus 1 into t. In the absence of a plate, the central maximum is formed at O. Due to the introduction of the plate, the central maximum shifts to point P, at which the optical paths travelled by rays from A to B are equal. In the absence of the plate, the path difference BP minus AP is equal to XD divided by capital D. In presence of the glass plate, the path difference is equal to BP minus AP, which is equal to XD divided by capital D minus of mu minus 1 into t. If P corresponds to the position of nth maximum, then XD divided by capital D into mu minus 1 into t is equal to n lambda, which is equal to solve for x, which is equal to n lambda plus mu minus 1 into t times capital D divided by small d, which is equal to n d lambda divided by small d plus d into mu minus 1 into t divided by d. In the absence of the plate, the nth maximum is at a distance of n d lambda divided by small d. The shift in the position of nth maximum is x is equal to nd into lambda divided by small d plus d into mu minus 1 into t divided by small d minus n into d into lambda divided by small d, which is equal to d into mu minus 1 times t divided by small d. It is that the shift in the nth fringes is independent of the fringe number and is same for all the fringes. Thus, introduction of a glass plate does not change the fringe width. The thickness of a glass plate is related to the shift in the fringe pattern by relation small t is equal to xd divided by capital D into mu minus 1. Thus, by determining x, d and capital D from the experiment and by assuming the value of mu, it is possible to determine the thickness of a thin glass plate by using interference phenomena. Alternately, if thickness is known, the refractive index of the material of the medium can be calculated. Okay, we shall discuss some questions on the session. Question number 1. Lloyd's mirror is an optical device for producing dash fringes. Options: Option A, interference. Option B, diffraction. Option C, polarization. Option D, none of the above. Lloyd's mirror is an optical device produces for the interference fringes. Therefore, the answer is option A, interference. Second question. A biprism consists of dash thin prisms. Option A 1, option B 2, option C 3, option D none of the above. A biprism consists of two thin prisms, therefore answer is option B 2. Thanks for patient listening.